Okay, in this video we're going to be looking at revision for univariate data again, but this time we're going to look at the short answer questions in the chapter review. Okay, let's get started. In question 1, for each of the following, indicate the type of data that would be formed. Your answer should be one of the following: nominal, ordinal, discrete, or continuous. Okay, for part A, the time taken for each member of the class to get to school, that's going to be continuous. Times are nearly always continuous because continuous data can take on any value in a range, which times can. For part B, the number of goals scored each week by a soccer team. So in soccer matches you can only get scores like 1 goal to 2 or 3 goals to 4. Values like that. You can't get 3.5 goals in a soccer match. Can't happen. Okay. That means it's discrete data because you can only get certain values for the scores. You can't get any old value like you can with continuous data. So this one is discrete. Okay, in part C, people are asked which of 5 designs they like as a new flag. So when people are choosing from their 5 options, they might be presented with 5 pictures. Okay. And each of these pictures might have a name. So this one's called something or other, this one's called another name, this one's called another name. So in fact, we've got nominal data here because it's clearly not discrete or continuous. We're not dealing with numerical data. Our options are designs, they're not numbers. And it can't be ordinal data because there's no order to these designs. They're just 5 different designs. So the only one that we're left with really is nominal. Although it is a bit of an odd type of nominal data. Normally we think of a series of names for nominal data, but nominal data is pretty flexible. It can fit in anything as long as it's not numerical and as long as it's not ordinal. Okay, in part D, we're talking about the annual income of each teacher in the school. Okay, now obviously that's going to be pretty pitiful because teachers don't get paid nearly as much as they should given the tremendous work that they do. But the kind of numbers that we're going to be talking about are maybe, let's say, $50,000 might be one teacher in a school. Another teacher might get $60,000. Okay, now while there's a lot of variation between the values that can occur, okay, it's conceivable that you might get a teacher being paid $55,563. It's possible you could get a teacher being paid that much, but there is a limit to how detailed these answers can get. Okay, they might even go down to the cent. There might even be a teacher who gets this amount of money, 55 cents, but it's going to stop at that point. Okay, we're not going to be able to get a teacher who earns $55,673.55 and add a few more decimal places on there. Okay, this can't happen because you don't get paid in this fraction of a cent. Nobody does that. I've never heard of it happening in my entire life. Okay, so the annual income, it is limited in how detailed it can be and how specific it can be. That means it's not continuous data. Okay, it can't take on any value. It can only take on certain discrete values limited by the size of the currency in Australia, which is at its smallest value, cents. Okay, so this one, D, is going to be discrete data. Okay, in the next question, the number of pages in each novel submitted for this year's Miles Franklin Award. So the kind of data that we're looking at, it's the number of pages in a novel. Okay, so obviously it's numerical, so it's either got to be discrete or continuous. Now the number of pages in a novel, you can't have half a page of a novel or a quarter of a page in a novel. You can't divide it up into fractions of pages. So that means it can't be continuous. It's got to be discrete again. Okay, the number of pages can only take on certain values, and in this case it's whole numbers, 1, 2, 3, 4, 5, etc. Okay, finally, people are asked to judge their level of contentment with life and are given a number of alternative responses with which they can answer. Okay, so this is sounding like it's not a numerical question, because the kinds of answers that people are going to give are about their level of contentment. Okay, it's probably going to be a worded response. Might be things like good, really good, great. Okay, it's going to be responses like that. And when you're setting out responses like that, there's clearly going to be an order to the responses. If it's a level of contentment, then the responses are going to have levels from higher to lower. Okay, so this is going to have to be ordinal data because there is an order built into the responses. Alright, let's move along to the next question. Okay, in this question, we've got 30 customers at a supermarket and they were asked to take part in a taste test of a new product. Each of the customers was asked to rate the product by choosing one of the words poor, fair, good, or very good, or excellent. Okay, and here are the results. So there should be 30 responses here amongst all of those. And we've got to first display the data by using a dot plot. Okay, let's do that. Okay, to make the dot plot, we can start by putting just a line to separate our labels from our dots. And we'll just put a letter underneath 5 sections of the line for where we're going to put a dot. Okay, these are kind of like columns in the bar graph. So this one's poor, fair, good, very good, and excellent. Okay, now let's go through the data that's provided, and each time we get a score, we're going to add a dot to the relevant column. So the first score is G, so that's 1 for good. The next one's also good, so I'll add another dot to that one. And the third one's V, so I'll add another dot there. Notice that when I put a dot in a second column, I'm keeping it even with the corresponding dot in the other column, so that they're going to be nice, neat rows and columns, a nice grid. Okay, I'm going to skip ahead. Okay, we've jumped into the future, and you can see now the completed dot plot. And it's just worth noting that the rows have been maintained. So if there's a dot in one column, I can go across and find a matching dot in the other columns. It would be very messy if we had dots out of rows, and the dot plot wouldn't be as meaningful in telling us about the shape of the data and the height of each column. Okay, now that we've done A, we can move on to B. We've got to find the frequency of a response of good or better. Okay, the frequency is just saying how many responses were there for that particular category, how many scores were there in that category. To do that, we need to tally up the number of scores for each of these columns. Okay, that's just counting the how many dots are in each column. Okay, for good or better, that's going to include all the columns from good onwards. Okay, so good, very good, and excellent. So if we add those together, we get 24. So there were the frequency of good or better was 24. There were 24 responses of good or better. For C, we've got to find the relative frequency of a response of good or better. Okay, relative frequency means relative to the overall score. So 24, it's going to be a ratio of 24, which are the responses of good or better, divided by the total number of scores, which we know is 30. We were told that at the beginning. There were 30 scores overall. So 24 to 30, we can simplify that down to 8 over 10 and 4 over 5, and that's about as simple as we can make it. The relative frequency of good scores or better to the total number of scores is about 4 to 5. 4 good or better scores for every 5 total scores. Finally, find the percentage frequency of a response of good or better. So that just means we've got to take our relative frequency for responses of good or better, which was 4/5, and convert it into a percentage. Okay, now if you're handy with percentages, you might be able to see straight away that that's 80% of 100%, 4/5. But in order to calculate it, if you didn't know how to sort of see that, the way to calculate it would be this. Okay, you'd take your 4/5 and then just multiply it by 100%, which will come out to 400% divided by 5. 4 times 100 is 400. Divided by 5 equals 80%. You can put that into a calculator if you need to. Okay, so there we go. That's question 3 done. Let's move on to the next one. Okay, in question 4, we've got some data provided, and this data tells us the number of maths subjects taken by 30 students over a 2-year period, the year 11 and 12. Okay, so each of the 30 students did a certain number of maths subjects. They either did 0 maths subjects, or 1 maths subject, or 2 maths subjects, or some of them did 3 maths subjects. Okay, so we've got all 30 students, how many maths subjects they did. That's what these scores are telling us. Alright, now we first need to represent this data on a frequency distribution table. Okay, what's that going to look like? Okay, in a frequency distribution table, we're going to have the scores, so what the possible scores are. In this case, there's 0, 1, 2, or 3. We need to have a row for each of those. It's very useful to have a tally column for a set of data like this, because we're going to have to go through the data and count up how many of each number there are. You don't have to have a tally column, but it does make it easier. And then once we've got the tallies, we can count up how many scores there are for each number, how many results there are for each number, and that's going to be the frequency. So let's skip ahead. Okay, once we go through the data, and for every 1 we put a dash in the one row, for every 3 we put a dash in the 3 row, and so on until we've tallied up every score. Okay, we get these frequencies. These are the frequencies we come up with. So that's our frequency distribution table done. Okay, next we have to draw a histogram of the data, and here's one that I've prepared earlier, as they say on the cooking shows. So in the histogram, we put the frequency on the vertical axis, we put the different possible scores on the horizontal axis along the bottom there. Of course, we've got to have a title and we've got to label our axes. And for the first score, the first possible score, which was to do 0 subjects, in our frequency distribution table, we found that there were 6 students who did that. So that's why this box goes up to the height of 6 frequency. 0 math subjects done by 6 students. For 1 subject, there were 8 students who did that. So on the table, you can see it goes up to pretty good approximation to 8. For 2 subjects, it was 12, and for 3, it was 4, just as in the frequency distribution table. So that's the histogram done. Okay, we need to add a polygon to the histogram. In order to do that, we have to start the polygon always just half a bar before the start of the first box. So that's just down here. And then we've got to connect it up to the midpoint of each of these, of the top of each of these boxes, of these bars. Okay, and the final point will be half a box in front of the final bar on the 0 for 0 frequency. So now that I've drawn those dots, I can connect up all the dots, hopefully with straight lines. My lines are not very straight because it's hard to draw straight on this with this device, but there's a pretty rough polygon. Hopefully yours will be a bit nicer and straighter than mine, but that's not too bad. Okay, so we've added the polygon to the histogram. That's that part done. Now we've got to ask, what was the relative frequency of 2 math subjects? Okay, 2 math subjects. The frequency of doing 2 math subjects was 12. The relative frequency means we've got to compare how many students did 12 with the total number of students, which was 30. Okay, we've got to put a ratio of those two numbers together to get the relative frequency. We can simplify 12 over 30 down to 6 over 15, which is equal to 2 over 5. I'm just dividing each of them by common factors. So we get down to 2 over 5. That is the relative frequency for doing 2 math subjects. 2 students did 2 math subjects for every 5 total students. Okay, lastly, we've got to work out the percentage frequency of 3 math subjects. So first we've got to work out the relative frequency for 3 math subjects to do that. So 4 over 30, which is the same as 2 over 15. Okay, once we've simplified that as much as we can, then we just multiply it by 100% to turn it into a percentage. And that comes out to be 200 over 15%, which we can simplify down to, okay, that comes to 13.3%. So that's the percentage frequency of 3 math subjects. Alright, now let's move on to the next question. Alright, question 5. A researcher investigates the amount of money spent by 50 people in a local Coles supermarket on Friday night between 6 p.m. and 8 p.m. His findings are presented in the ogive shown at right. Okay, so we've got increasing amounts of money being spent by numbers of people. But really what this ogive, what this graph shows us, is that for a given amount of money, if we say identify this amount of here, $50, and connect it up to the line, it shows us that that connects up to about a cumulative frequency of 17. So it would mean 17 people spent $50 or less. They spent $50 or less because 17 scores are below that point of $50. So that's what the ogive's trying to tell us. Okay, and that's actually what the first question's asking. It's asking how many people spent $50 or less. To answer a question like that, like we just said, we start at $50 on the relevant axis. We go up to the data line. We've got to connect our question with reality, and that this data line is reality. This is the facts about how much people are spending in this situation. And then we go from the data line over to the cumulative frequency axis, and yep, that hits about 17 people, that means. So that means that 17 people spent $50 or less because there's 17 scores below that value of 17. So for A, 17 people. For B, how many people spent more than $100 on shopping? Okay, so let's find 100. Here's 100 on the x-axis, on the dollars axis. Let's draw a straightish line up to the data line, and then we go across from that point over to the cumulative frequency axis. Okay, and we find that that's hitting very close to 45. It might be, we might be 1 or 2 off, but it's pretty close to 45. But this time we're asking how many people spent more than 100. So the question is, how many people are above this point of 45? And in order to work that out, we need to work out how many people are there from 45 up until there's no more people. Okay, and we were told in the question that there were 50 people involved in this survey, involved in collecting this data. So from 45 up to 50, there can only be 5 people in that gap from 45 up to 50. Again, we're interested in how many people spent more than $100 on shopping. So we're interested in the data above this point on the data line, not below it, as in the previous question, above that line. There's only 5 scores above that line from 45 up to 50. 5 scores or 5 people. Okay, and the next question, what percentage of people spent less than $80? We need to work out a percentage answer for this question. So we're going to have to add a percentage axis to our ogive, which really should be on every ogive. Let's add that percentage axis now. Okay, so here's our percentage cumulative frequency axis. It's pretty easy. Just at the maximum amount of cumulative frequency, at in this case 50, that must be 100% of the cumulative frequency scores. So we put 100 there, halfway below that we put 50, halfway below that we put 25, and halfway in between 50 and 100 is 75. So that's very easy to add that axis. Okay, back to the question, what percentage of people spent less than $80? So as before, we find $80 on our horizontal axis here. We draw a line up to the data line, but this time, because we want a percentage answer, we're going to go across to the percentage axis. And I estimate that that's hitting that percentage axis there around 70%. Pretty close to 70%. And since we're asking about less than $80, okay, there's 70% of the data below that line. It's the 70th percentile. So 70% of people spent less than $80, according to my estimation. Okay, in part D, find the 80th percentile of the data and write a short sentence explaining what it means. Okay, the 80th percentile of the data is going to be pretty close to here. Oops. Let's try that again. So very close to there is about 80%. We connect that to the data line and again go down, try and go straight if we can, down to the dollars line, and we've hit that, I would say about $95, pretty close to $95. So $95 is the 80th percentile, and we've got to explain what that means. Okay, $95 is the 80th percentile. What does that mean? Okay, if $95 is the 80th percentile, that means that 80% of the scores in this data set were below $95. That's what the 80th percentile means. Now let's bear in mind that when we're calculating these kinds of values from an ogive, it's quite possible to have differences of opinion. Okay, for one thing about the straightness of lines, for another thing about where exactly 80% fits on this cumulative frequency axis. You know, we're making estimations, so we're going to expect some discrepancy between answers. And on a test, given a question like this, you'd be allowed a bit of leeway in your answers. You know, a few dollars either way or a few percent either way would still be given a correct answer. So there isn't just going to be one, although there is probably one exact correct answer, given that we're estimating on a graph that's not exactly clear, we have to allow for a bit of error on either side of our answers. Okay, finally the last question, E. If Nathan was in the lowest 10% of buyers, what is the maximum amount of money he could have spent? Okay, the lowest 10% of the buyers, we're going to have to find 10% on our cumulative frequency, percentage cumulative frequency axis over here. I'm going to estimate it's about there, and I'm going to draw as straight a line as I can over to the data line, and then go down to the dollars axis, and I find that I'm hitting that at about $15 or so. Okay, so at $15, below that point we've got the lowest 10% of buyers, so $15 would be the maximum amount that he could have spent. He may have spent less than that. He may have spent anywhere from 0 down to up to $15, but they want to know the maximum amount of money he could have spent. It would be $15. Again, give or take a few dollars either side of that because of the fact that we're estimating imperfectly. Okay, and that's question 5. That's interpreting ogives. Let's move on to the next one. Okay, in this question, we've got a series of scores, and we've got to find all of these statistical values. Okay, some of them are measures of central tendency, and others are measures of variability. Okay, to help us do that, we're going to use our trusty old calculator, and we're going to enter in all the values in the list that are provided to us. So 2, 6, 9, 1, 3, 5, 6, 7, 8, 2. Once we've entered the numbers into the list, we can put them in order if we like. Just go sort ascending and just go OK, OK. So we're dealing with list 1. And now the numbers are nicely in order. And we can go calc, one variable. We're only interested in list 1, so we go OK. And it's given us all the statistics we need to answer these questions. The first one in the list is x bar, which is 4.9. So x bar is the mean, and we're told that that is 4.9. Okay, the median, if we go down our list of statistics, we're told is 5.5. So we can put 5.5 down as the median. The mode, if we go down, it says there's actually 2 modes. It's got mode equals 2 and mode equals 6. So it seems that there are 2 modes. And if we look at the data, we can see, yeah, there's 2 2s and there's 2 6s. So that's the equal highest number of scores for any given value. Okay, for the range. Now, it doesn't actually give us the range amongst this list of data, but it does give us what we need to work out the range. The range is the maximum value minus the minimum value. So range equals max minus min, and the maximum we're told is 9, the minimum we're told is 1. We probably could have worked that out ourselves if we wanted to, but we've got the calculator, we might as well use it. So the range is 8. The interquartile range, IQR, is Q3 minus Q1, and in here we can see Q3 is 7 and Q1 is 2, so 7 minus 2 equals 5. That's the interquartile range. The standard deviation is SX, so that's 2.77 if we're adding up. And then the variance is going to be the standard deviation squared. So we just need to square the standard deviation of 2.77. And if you put 2.77 squared into a calculator, then you get 7.67. So there we go. That variance is 7.67. So when you use a calculator, it's pretty easy to find all of these values. Alright, on to the next question now. Okay, so here's question 7. This time we've been given a table, and the first thing to notice about this table is that this is grouped data. Okay, so we don't have individual scores anymore with frequencies. We've got groups of scores, and we know how many scores are in each group. So in this group, which covers the range from 30 to 40, there's 3 scores in there somewhere. We don't know what they are exactly, we just know they're somewhere in there. In the group 40 to 50, there's 6 scores in that group, and so on. Okay, so this is a different kind of data. It's going to require finding these values, the mean, the median, and so on, in a different way. Okay, the first thing that's going to help us to find these values, mean, median, and so on, is to add a couple of extra columns to our table. Okay, let's put those columns in. Okay, these are the 2 extra columns that we needed to add. We've added a midpoints column, because for each of these scores, we're going to need to have actual scores that we can add together for the mean, or that we can count between for the standard deviation. And in order to do that, we have to estimate what the scores in this group are. We need specific scores. So we're going to estimate that all the scores in this group are 35, all 3 of them. All the scores in this group are going to be 45. We've chosen those midpoints because they're in the middle of that group. 30 to 40, the midpoint is 35. It's the best estimate of a score in that group. Okay, the other column we've added is a cumulative frequency column, which shows us how the scores are accumulating as they go from group to group. Okay, for the above data set, find the mean. Okay, for the mean, we can use a calculator. Okay, so into our calculator, we're going to put the midpoints. We have to put actual scores in, so we're going to put the midpoints in. 35, 45, 55, 65, 75, and 85. and we better get rid of these other scores. Okay, then in list 2, we're going to put the frequencies of each of those groups. How many times each of those scores occurred. Okay, so put those in. And now we've reproduced the frequency distribution table in a slightly modified form in the calculator. Okay, now when we go to calc one variable, we want to have list 1. That's where our midpoints are. But the frequency column was in list 2. So we need to choose list 2 there. Then we go OK, and we get all our statistics that we need. Okay, we've got the mean is x bar 65.78. So 65.78 is our mean. If we go further down the list of statistics, we find that the median is the group containing the midpoint of 65. So it's not saying that the median, the calculator is actually saying the midpoint is 65, but we are not going to make that guess. We're going to limit ourselves to saying that the median group, which is what the question's asking for, was the group containing that midpoint 65. Okay, so the median group is the group 60 to 70. The modal group, the calculator says, is the group containing the midpoint 75. Okay, so it's told us that this is the group containing the modal, it's the modal group, it's the group that contains the modal midpoint, and that group is 70 to 80. Okay, the range, we can't actually get the range from the calculator because the calculator doesn't know about these groups. We've only told the calculator about the midpoints, and those midpoints are not going to tell us the range. To know the range, for group data, we go to the start of the first group, okay, which is 30. The start of the very first group. It's the lowest possible score in this data set. And then we call the maximum value the top of the highest group, the uppermost value in the highest group. So this uppermost group is 80 to 90. Okay, and so the highest value would be 90. So our maximum is 90, our minimum is 30, which makes the range 60. Okay, so there's our range, 60. That's the gap from the lowest possible score to the highest possible score. The standard deviation. Okay, we are going to have to defer back to the calculator for this. The standard deviation, according to the calculator, is 13.84. I've rounded the 3 up because of the 6 that's after it. So 13.84 is the standard deviation. The variance is going to be the standard deviation squared. So if we square that, let's see what we... Okay, when we square the standard deviation that we got in that previous question, then we get 191.44. So there's question 7 done, and we can move on to the next one. Okay, in question 9, we've got two side-by-side stem and leaf plots. We've got a side-by-side stem and leaf plot, and it shows the number of lessons per week given by two piano teachers, Victoria and Elena, over a period of 30 consecutive weeks. So each week, the number of piano lessons given by each of these people was counted, and it was recorded. And that's what we see here, how many piano lessons they gave each week. So for example, in one particular week, Victoria gave 3 piano lessons, 0 and 3, according to the key, means 3 lessons. In another week, she gave 2 and 0, she gave 20 lessons. In another week, she gave 3 and 3, 33 lessons. Okay, now the first part of this question asks us to derive a 5-number summary for each set of data. Well, I've done that over here because it would have taken quite a long time to go through it step by step, showing you everything. So I've just done it. The minimum, the maximum. The minimum was easy to obtain just for Elena. This top set of data is for Elena. You just had to look at the stem of 0, and the first leaf, the one closest to the stem, was 2, so the minimum had to be 2. For the maximum, went down to the last leaf, which was here, 2 and 5, made 25. Okay, for Q1, Q2 and Q3, you just had to find, for the Q2, the median of the whole set, which meant you had to look at the number of total number of scores plus 1 divided by 2, the 15.5th score. You find that in the list. And importantly, this is an important thing to note. When you're finding the median on the left-hand side of a back-to-back stem and leaf plot, so on this side, you've got to make sure that when you're counting from right to left. So I'm looking for the 15.5th score to find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.5 is in between these two numbers. So that's 11 and 12. So it was important that I counted from right to left, okay, from the smallest numbers towards the largest numbers. If I'd counted from left to right, I would have ended up with a different median. It would have been the wrong median. I would have ended up around here somewhere, maybe there. Okay, so it's important that you're counting from smallest to largest on both sides, and on the left hand side that means counting from right to left as you're going through each stem. On the right hand side, obviously you're counting from left to right because they're ordered from smallest to largest, going from left to right, but on the other side it's the opposite. Okay, so we found the median, and then to find Q1 and Q3 we just had to find the 8th value in the upper half and the 8th value in the lower half. Okay, and we ended up with this 5-number summary for Elena, and following the same process we ended up with this 5-number summary for Victoria. So that's the 5-number summaries. Okay, next we had to draw a side-by-side box plot of the data. Okay, in order to draw the side-by-side box plot, we first need a scale, and this scale has to go from 0 up to 40. It has to go from 0 to 40 because that's the range of the scores. They start just around very close to 0, just above 0, and for Victoria they go all the way up to 35 or just under 40. So our scale needs to cover that distance. Okay, now our 5-number summaries can be used to create the 2 box plots. So for Elena, the start of her box plot is going to be at 2, which I estimate to be around here. So that's the dot at the end of the box plot. And then Q1 is 6, which is about here. So I'm going to put a line there for the start of the box. 11.5 is the median. I reckon that's about there. 15 about here. So that's our box. And then 25 is right there. So there's our 5 key points. Now we can draw the box, draw the whiskers, connecting up to the dots, and there we go. It's a pretty ugly looking box, but it'll have to do. Okay, for Victoria, we've got a 3, which I estimate to be around here. We've got 14, which is about there. That's the start of the box. Q1, 20 is the median, 26 is Q3, the end of the box, and 35 is the maximum down that end. So we can draw the box around all of that, connect it up to the whiskers, and it's another ugly looking box, but another ugly looking box plot, but it really does tell us what we want to know. It tells us where the key points are, and it allows us to compare the spread, the variability of the 2 data sets, and it certainly allows us to see that Victoria was giving a lot more piano lessons than Elena. That's pretty clear to see. So we've drawn a side-by-side box plot of the data. I should just label this one Elena, and I should label this one Victoria, just so we're clear. Okay, lastly, we need to make comparisons between the 2 sets of data. Use statistics in our answer. Okay, so some comparisons that we can make. Victoria had a greater range. So she had a bigger range. She had a higher median. Her data was more like a normal distribution, whereas Elena's was positively skewed. That's a little plus sign for positively skewed. That's Elena's data because it's a little bit over to the left, which, as you should know by now, is the opposite of what you would think. It's, instead of being called negatively skewed because it's down the negative end, it's called positively skewed. And as far as statistics go, the range for Victoria was 32, and the range for Elena was 23. So that shows the greater range of Victoria's, the number of piano lessons Victoria was giving. Okay, for the median, we can see the median for Victoria is 20, and for Elena the median was a lot less. It was only 11.5. So that's that key indication of the median is a measure of central tendency. It shows Victoria had a much higher median number of scores than Elena. So that's probably enough for a statistical comparison. Okay, on to the next question. Okay, these next few questions are extended response questions, so they're a bit longer. They require a bit more analysis. In question 1, so there was an upcoming debate, and Rachel, who was the debating team captain, she decided to conduct a small survey. She asked a number of students whether they agreed with the following statement. Language other than English, or LOTE studies, should be a compulsory subject in years 7 to 10, and students were given a choice of the following options. Strongly disagree, disagree, not sure, agree, or strongly agree. Okay, Rachel recorded the responses in a dot plot we see over here. Okay, let's look at the questions. How many people participated in the survey? Okay, to work out how many people participated in the survey, we're going to have to count up the dots. Now you can do that yourself, but I'm going to do my count. Okay, I counted 30 dots in there, so 30 people participated in the survey. The next one, state whether the data obtained in the survey are categorical or numerical. Well, because the answers that people were being asked to give were words over here, it's clearly not numerical. Okay, the answers weren't numbers. So it was categorical data. Categorical. Okay, in part C we have to classify it further. So we know it was categorical data, so we can cross out discrete and continuous. Was the data nominal or ordinal? Okay, now clearly there's an order to these responses. They're not just random selections in a category. There's a clear order to them, from strongly disagree, so sort of a negative response, gradually becoming more positive, to be eventually really positive. So this is ordinal data. In part D, we have to represent the information by using a bar chart. Okay, for part D we had to represent the information with a bar chart. So to save time, I've cheated a little bit by putting a bar chart around the dot plot, and I've just added the frequency axis here, and this axis stays pretty much the same. Notice that the key features of the bar chart are that there's a gap between each of the bars. Okay, the bars correspond to a height, the height of the frequency, which should be matched up with the scale on here, and that's about it really. Okay, in part E, construct a frequency distribution table for the data. We must have a title for the bar chart as well. Construct a frequency distribution table for the data. Okay, so here's our table. The different categories are strongly agree, strongly disagree is first one, disagree is the second one, and then not sure is the third one, agree and strongly agree are our 5 categories. Okay, once we've done that, then this is going to be the frequency here. So frequency distribution table, there are 6 strongly disagrees, there are 9 disagrees, there are 8 not sures, 5 agrees, and 2 strongly agrees. So there's a frequency distribution table. Okay, so in the next question, we have to work out what was the relative frequency of students who agreed with the proposed statement. Okay, so agreed, that's this response here. There were 5 people, 5 dots there, so 5 people who agreed with that statement, and out of 30 responses. Okay, relative frequency calls for comparing that particular response with the total number of responses. So 5 over 30, that simplifies down to 1 over 6. The relative frequency was 1 out of 6, or 1 over 6. Okay, for G, we had to find the percentage frequency of students who were not sure about their response. So not sures there were 8, and that was again out of 30. So that's the relative frequency of not sures, but we have to convert that into a percentage. So we need to multiply it by 100%. And if you put that into a calculator, 8 over 30 times 100%, then you'll get 26.67%. Okay, and finally for H, a particular response option was selected by 20% of all students. What was that option? Okay, which option had 20% of the responses? Well, 20% is the same as 20% of 30 is the same as 0.2 times 30. And if we put that into a calculator, then we will get 6. So we're looking for a response that had 6 people responding to it. Okay, and that is this one here. Strongly disagree had 6 dots, which means 6 people responded to strongly disagree. So that was the option that had 20% of all student responses. So there we go. Question 1's done. Let's move on to the next question. Okay, in this question we're provided with lots of information. We've got 2 tile shops, Designer Tiles and Nathan's Tiles, and it's telling us about the price per square meter of the different tiles that they have. Okay, the first thing I'd like to do upon seeing this is to try and draw a bit of a rough polygon around the histogram to give us a better idea of the shape of the data. Okay, that's going to help us later on. Now let's look at the questions. For each shop, describe the distribution of the data shown by the histograms. Okay, so for A, we've got to describe the distribution of both sets of data. So Designer Tiles, how can we describe that? We've got to use these common terms that we've heard, like normal distribution or skewed distribution, clustered, and so on. Okay, the best way to describe this would be it's skewed, and it's skewed over to the positive side or to the higher end, but counterintuitively that's called a negatively skewed data set, or a negatively skewed distribution. So that one's negatively skewed. Nathan's Tiles is skewed in the opposite direction, so it's positively skewed. Okay, for part B, we need to use the histograms to arrange the data for each shop into frequency distribution tables. Okay, so in order to use the histograms to create frequency distribution tables for each data set, I've created my table. I'm going to start with Designer Tiles. I'm going to put the information into the table. Okay, so for Designer Tiles, the first group starts at 20 and it goes up to 30. The second group starts at 30, it goes up to 40. So I've represented that here. And the frequency for the first group is 2, as you can see there. For the second group, it's also 2. Okay, I'll jump into the future and put the rest of those in. Okay, so there's the frequency distribution table for Designer Tiles, and you'll notice I've left room in my table there for other columns in case we need those later. I'm just going to shrink this down a bit. And now we can create the table for Nathan's tiles. Okay, so there's the information for Nathan's tiles in a table as well. Okay, now to calculate the necessary statistics for Part C, the mean, median class, modal class, range, standard deviation, we're going to use the calculator to speed that up, and we're also going to have to add a couple of columns to each of these tables. Okay, so we've got room for the midpoint column in each table, so let's add in the midpoints for each group. And I've just shrunk them down a little bit and moved them as well. So now we've got the midpoints for each group. We can enter the data for each one. We'll do it one at a time, but we'll enter the data into the calculator. So here's the data for Nathan's tiles. We've got the midpoints listed here, and we've got the frequencies listed in this second column, list 2. Okay, so we just go to calc and one variable, list 1, we've got to choose frequencies to be list 2. That's where we put the frequencies. And here we've got all the statistics we need. So we can write those in. So the mean, this is for Nathan's tiles, was 50.62. The median class, so where to find the median, was the class containing 45, which is the 40 to 50 class. We could just say 40 with a hyphen, but we'll say 40 to 50. The modal class, if we go further down, was again the 45, the class containing the midpoint 45, which was the 40 to 50 class. And the range, we just need to look at the, well, actually we're not going to be able to get the range from the calculator. We're going to have to look at the table. The lowest part of the first group is 20, and the highest part of the last group is 100. So it's 100 minus 20, which is 80. The standard deviation we can get from the calculator. That's SX 16.72, rounding up. 16.72. There we go. Okay, next we need to work out the values for designer tiles. So the midpoints are actually all the same. We just need to change the frequencies. So they'll be 2, 2, 5, 8, 10, 10, 12, and 9. So with those values, we go to calc, one variable, list 1, list 2, okay. And here we are with our new statistics. So the mean this time is 70.17 for designer tiles. The median class is the class containing 76, because I put the wrong value in there. Let's fix that up. Let's make that 75. That might have affected the values in here possibly a little bit as well. These might be a couple of decimal places off. But let's go back here. So yep, the median class was the class containing 75, which was 70 to 80. The modal class was 85, so 80 to 90, that's the class that contains the 85. The range was it would be the same as for Nathan's tiles because the groups are the same. And the standard deviation, SX, is going to be 18.85. 18.85. There we go. We've got all the statistics for those two sets of data. Okay, and I've just noticed that after we changed that that mistake in the list of data, the 76, we changed it to 75. That's fixed our mean so that it's now exactly 70. It's no longer got this decimal place there. Okay, so we can move on to the next part. Use the statistics obtained in Part C to compare the buying trends in the two shops. Okay, Okay, the key thing to notice about the differences between the designer tiles and Nathan's tiles, the mean, the median class and the modal class are all higher for the mean, the median class and the modal class for Nathan's tiles. Okay, so the measures of central tendency are all higher. These are all measuring prices. So people are buying more expensive tiles at designer tiles than they are at Nathan's tiles. That's the key thing that these statistics are saying. Okay, Nathan feels that he needs to rearrange the stock in his shops. He plans to increase the range of cheaper ceramic tiles in Nathan's tiles. He also wants to move most of his expensive porcelain stock to designer tiles. Would you support Nathan's decision? Justify your answer. Okay, well, his decision seems to make a lot of sense to me, because if he increases the range of his cheaper ceramic tiles, and for Nathan, that's what he's selling more of. He's selling lots of cheaper ceramic tiles at the moment because his median price is lower, his median class is lower, the mean is lower. He's selling cheaper ceramic tiles, so he should get more of those in. That's what he's saying he should do. Increase the range, get more cheaper ceramic tiles in, more different kinds, and he'll probably sell those if he gets them in. He also wants to move his expensive tiles to designer tiles because look, they're having lots of success selling expensive tiles. So he figures if he moves his expensive tiles down to designers, then they're going to sell better than they are at his place. For some reason or other, people are buying cheaper tiles from him and more expensive tiles from designer tiles. So very smart move on Nathan's part. Okay, we'll stop there. Thanks for watching the video, and I hope you found it helpful.